the next thing that I want to talk about is the average rate of change. And what we mean by average rate of change is basically when you have the slope of a line, your slope of a line is the ratio of the vertical change in y to the horizontal change in x. Now, we've already talked about this. So when you have this vertical change, the ratio of the vertical change to the horizontal change, what happens is that the slope gives the average rate of change in y per unit of change in x, where value of y depends on the value of x. So that's basically what we mean by the average rate of change. In simple terms, you can think about it as when you're talking about an application problem, the average rate of change is basically the slope of the line for your given ratio. That's basically what we are talking about in those application values. So anytime you hear the term average rate of change, you want to think of the slope of that line. So to understand this average rate of change better, let's go ahead and look at an example here, an application problem. This one is right out of your textbook. So we'll go ahead and look at this problem here. Now, the example is about the number of drive-in theaters in United States. You have a graph here from the year 2000 to the year 2004, and it says the graph provides a good approximation of the number of drive-in theaters in the United States from 2000 through 2004. Now, using this graph here, we need to come up with, use the given ordered pairs to find the average rate of change in the number of drive-in theaters per year during this period. So you have to find the average rate of change. And part B says, explain how a negative slope is interpreted in this situation. So let's go ahead and first calculate our average rate of change. Okay, now again, remember, average rate of change, we're basically talking about the slope of this line. So we will go ahead and use our slope formula. Now, to use the slope formula, we need two ordered pairs to help us find that slope. If you look at this graph, you will see they're giving us two ordered pairs. In the year 2000, we had 512 drive-in theaters. And in the year 2004, we have 392 drive-in theaters. So we will use these two as our ordered pairs. So the y values will be 512 minus 392, and the x values will be 2000 minus 2004. So if you go ahead and solve this problem, you will see you end up with 120 over negative 4, and that will give us negative 30. So you can see that our slope turns out to be a negative slope, and that tells me we have negative, our average rate of change is negative 30 theaters per year. So what exactly does that mean when we say negative 30 theaters per year? That's what part B says, is to explain how a negative slope is interpreted in this situation. What the negative slope here means is that basically the number of drive-in theaters have decreased on an average of 30 per year. So, over the course of these 4 years, on an average, every year we've been losing 30 drive-in theaters approximately. All right, and that basically takes care of section 7.1.